Hello, welcome to the Global Azure Bootcamp Virtual 2020 edition. In this session, we're going to explore how organizations can harness the power of edge computing with the Azure Intelligent Edge ecosystem. We're going to discuss how to develop intelligent apps for edge and disconnected scenarios with Microsoft Azure, Azure Stack Hub, and Azure Stack Edge. My name is Janaka Rangama and I'm a Microsoft Azure MVP. I work as a Senior Principal Engineering Technologist for the APJC region at the Dell Technologies Microsoft Azure Stack Family Engineering Technologist team.
First, let's take a look at the intelligent edge and the cloud taxonomy. What are the products and services available from Microsoft to build an intelligent cloud and edge ecosystem? First, you have the hyperscale cloud, that is Microsoft Azure. It provides a plethora of cloud native services to deploy your applications. That includes containerized services, AI services, things like that. Now, what about when you want to run the Azure services on your own terms, or rather in your own data center? That's where Microsoft Azure Stack Hub comes to the play. Microsoft Azure Stack Hub is an extension of Microsoft Azure, where you can run Azure services locally from your data center. It contains a subset of Azure services which are specifically targeted for those scenarios. What about running Azure native services at the edge or maybe in remote site, and you want a local appliance with a reduced physical footprint? That's where Azure Stack Edge comes into play. It's a small appliance capable of delivering a small subset of Azure native services that requires a minimum amount of compute power. What about your good old virtualized software or virtual machines or your old school NTR applications? They too have a space in the Azure Stack ecosystem. Azure Stack HCI is a software-defined solution where you can run your virtualized workloads, and you can use those virtual machines the same way that you want to do your compute enabled processing. Now, all these processing powers or the processing models or the cloud models that we discussed require some sort of input. In the intelligent edge ecosystem, you can leverage IoT devices or microcontroller based devices to provide input to these systems. For an example, the smartwatch you wear now could be turned into an IoT device. And with Microsoft Azure Sphere, there are a plethora of MCU solutions now available to the customers. Let's discuss what Azure Stack Edge is. Azure Stack Edge provides hardware accelerated machine learning. It can provide machine learning inferencing using an onboard FPGA or a dedicated GPU. When you have a local FPGA or a GPU, you can provide the results to your machine learning experiments closer to the data source. No need to send back for the cloud for processing. Like I discussed earlier, it can provide the necessary compute power for your edge applications. Maybe to run virtual machines or containerized workloads, Kubernetes, Azure services, pretty much at edge locations. The beauty of this solution is you're purchasing that through your existing Microsoft Azure agreement. You simply order and manage your appliance and its workloads through the Azure portal. You can also use the Azure Stack Edge as a storage gateway. For an example, the data you collect locally in your data center or your edge site, you can transfer those to Azure over the network when you have the connectivity, and you can keep local access to blobs and files because you can decide which data resides inside the Azure Stack Edge, and it will be presented as blobs and files. To summarize, Azure Stack Edge is capable of providing machine learning at the edge, ideal for edge compute and ideal solutions, and it can do network data transfer from the edge to the hyperscale cloud. What about the Azure Stack Hub? Now, the Azure Stack Hub, as we discussed, is an extension of the hyperscale Microsoft Azure public cloud. It is, however, a complete autonomous cloud. Now, this is only consistent true hybrid cloud where you can run it either as a connected appliance or a disconnected appliance. Also, it provides a consistent application development and operations platform. So the same tooling you use with your Azure development today, like Visual Studio, Azure DevOps, you can use the same tooling to work with Azure Stack Hub. Like I discussed earlier, Azure Stack Hub provides Azure services on premises on your own data center as an appliance. There's a subset of services available which we are going to discuss in the next slide, but in a nutshell, it can literally provide the necessary compute, network, and storage capabilities backed by those Azure resource providers to deploy your cloud native application. Remember, this is not do-it-yourself hardware. It's a purpose-built integrated system. What does that mean? So this appliance contains cloud-inspired infrastructure, basically a targeted version of the public Azure software running in an integrated system via major hardware providers. So remember, you can't have a do-it-yourself Azure Stack Hub system. To summarize, Azure Stack Hub can provide you Azure in a connected or disconnected cloud on your own data center. Ideal use cases for Azure Stack Hub would be regulatory or data sovereignty requirements. For example, financial sector, healthcare sector, and they want to use the Azure services but can't go to the public cloud quite yet. And application modernization. If you have old school applications and transform them into a cloud inspired model, you can first target them to an Azure Stack instance. There's zero to minimal code change required to port that to the public cloud because it uses the same platform as public Azure. Now, I promised that I'm going to discuss what are the number of services or the various services that will be available in each of these solutions, especially on Azure Stack Hub, on Azure Stack Edge. Now, as you know, there's hundreds of services available in Microsoft Azure. Given the size and the scale of Azure Stack Hub and Azure Stack Edge, only a small subset of services available today. For an example, Event Hubs, Service Fabric, Azure App Service, Azure Functions, Azure Stream Analytics, Azure API Management, Azure IoT Edge. These are some of the prominent Azure services that are available in Azure Stack Hub. Furthermore, we have IaaS virtual machines, storage accounts, things like that. But from a cloud native services perspective, the services I mentioned takes priority with Azure Stack Hub. With Azure Stack Edge, there's a little of physical footprint available. So it's one U appliance. From a cloud native perspective, you can leverage Azure Functions, Azure Stream Analytics, Azure IoT Edge with Azure Stack Edge. Now, with both of these solutions, you can reuse a number of AI resources combined with public Azure to deploy your AI-inspired applications. For an example, you can run Azure Cognitive Services as a containerized service available in Azure Stack Hub. You can use your trained Azure machine learning algorithms running on top of Kubernetes and Docker containers in Azure Stack Hub and Azure Stack Edge. You can use the Onyx AI runtime on top of both of these solutions. Now, let's see a sample application, a cloud native inspired application running on Microsoft Azure Stack Hub and discuss how the architecture is going to be. Event Hubs is a data ingestion service that is available with Microsoft Azure Stack Hub, Microsoft Azure as well. It acts as a front door to an event pipeline. For an example, imagine an application where your input would be streaming data, logs, files, media that are coming through, and maybe customer sentiment data, for an example like a Twitter feed, or a number of data coming through business applications. You can have those data, filter them, and send them through an ingestion pipeline using an Event Hub available on Azure Stack. Then, depending on your application model, you can process that data using a PaaS servers or an application running on a virtual machine and process that data locally within an Azure Stack Hub. And within the same Azure Stack Hub, you can save those data using Azure Blob Storage. Now, imagine a scenario where you want to do further process, store or visualize those data, and you need more compute and cloud power. A good example would be customer sentiment data, a Twitter feed where you want to see whether the customers are saying are happy about your product, or are they disappointed about the customer services provided, or what's their take on your products. So those data can be first filtered in the Event Hub available on the Azure Stack Hub, processed, and if you have anomalies or need further processing, can be sent to the public cloud, that is Microsoft Azure. So in Microsoft Azure, it can go through a bunch of Azure Event Hubs, and you can use Azure Stream Analytics to transform this data into Power BI dashboards. And you can use Azure Event Grid to trigger a series of operations based on Azure functions on those sentiment data. For an example, if a customer has put down a bad review and your local Azure Stack version of the application can't quite decide it, while you send it to public Azure for further analysis and it detects this is an anomaly, the customer is disappointed, you can trigger an Azure function to send an automated follow-up email message to that customer. Now, what about those data that you want to retain for your archiving or data warehousing purposes? You can use the Azure SQL Data Warehouse for that. So with public Azure, you can visualize, provide event-driven workloads, and store those data that you have processed in the hyperscale cloud. Let's see another example of leveraging Azure Stack Hub and Azure Stack Edge to develop intelligent edge applications. In this example, we would look at a retail store which would like to gain insights on how customers are receiving their current products based on their store layout. As a customer or a consumer, you would already know, depending on where the products are placed and how easily accessible they are, sometimes you might skip few sections because you may feel too lazy to walk in. Similarly, based on where these products are placed, this store would like to see whether they are currently selling fast or are there any products that are lagging behind. Practically, the store management cannot place staff in every section because they are short-staffed. And also it's inefficient to have a team of analysts review all the cameras in the store. So basically to review the whole CCTV footage. Also, these are retail stores. None of them would have enough bandwidth to stream video from all their cameras to the cloud for analysis. Now this store would like to find an unobtrusive, privacy-friendly solution that doesn't violate customers' privacy to determine their demographics, loyalty, and reactions to store displays and product. In this solution, there's a tiered approach to inference at the edge. As you can see on the left-hand side, the Custom Vision AI Dev Kit can capture only images with human faces, and then those images can be sent for analysis to a private Azure Stack Hub that is running Azure Cognitive Services containers. The anonymized aggregated data of the face analysis can be sent to Azure to aggregate across all the stores this retail chain might have and provide visualization on Power BI. By combining the edge and public cloud capabilities, this application allows the retail chain to take advantage of the AI technology and at the same time remain in compliance with their corporate policies and respect the customer's privacy. First, the Custom Vision AI Dev Kit gets configuration from an IoT hub and installs the IoT Edge runtime and a machine learning model. Second, if the AI model sees a person, it takes a picture and uploads it to a Azure Stack Blob storage. Then the Azure Stack Blob storage triggers an Azure function on the Azure Stack Hub. This Azure function calls a container with Face API to get demographic and emotion data from the image. These are all local instances of the Azure services running on the Azure Stack Hub. Then the data is anonymized and sent to an Azure Event Hubs cluster sitting in the public Azure cloud. The Azure Event Hubs cluster pushes those data to Azure Stream Analytics. Finally, the Azure Stream Analytics aggregates the data and pushes those data to Power BI for further visualization. Now, in order to scale this solution across multiple cameras and locations, you'll need to make sure those components can be very well within handling the increased load if you have many customers coming on Christmas Day maybe. So you may need to take actions such as increasing the number of Stream Analytics streaming units, scale out the Face API deployment that is running on the Azure Stack Hub cluster, and increase the event hub's cluster throughput when you have high demand for facial recognition. In extreme cases, you maybe want to replace the Azure Functions side of things in this solution with an Azure Virtual Machines if that comes to a point where compute is a blocker.
Well, I hope you learned a thing or two about the Azure Intelligent Edge ecosystem by attending this session. Thank you, and I hope to see you next year.